Hello guys. Last class already we had discussed with round robin scheduling algorithm. I said round robin scheduling algorithm is similar to your FCFS, but your FCFS is what non-preemptive scheduling algorithm. But your round robin, whatever it is there, it is totally what preemptive. As the name indicates, preemptive. Every process will execute only for what? Only for the time quantum what you are specified. And assume here, whenever they ask round robin scheduling algorithm, there should be what? Time quantum. How many seconds every process is going to execute. Okay, that's what your round robin will say. So here what happens is it is preemptive. So what happens is every process is going to execute only for the specified time quantum and then preempt to what? The next process. And here for this example I have just given time quantum as 1 millisecond. Why round robin fashion is going to execute for 1 second and next process, next process, next process, next process. If it is not completed, again round robin, again it comes to your first process and execute. So I'll just add all these things: 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 you have to get at the end. So I'll write the Gantt chart. So I show that it starts with what? It starts with 0 second. Okay. So which will execute is first process P1 executes only for what? Time quantum 1 millisecond. Remaining is how much? 6. Next process FCFS, right? Next process that came is your P2 executes only for what? 1 second. So it becomes 2. Remaining is what? 1. Next P3 process execute for 1 second. It becomes 3. Remaining is how much? 2 here. Next P4 execute for 1 second. It becomes 4. P4 completed. Okay. Next P5 it executes for 1 second. It becomes 5. Remaining is so much? 2. Again see round robin. Again comes to your first process. P1 will execute for 1 second. It becomes what? 5. Again P2 it executes for 1 second. Completed. P2 process completed. Next P3 process 1 second executes. Remaining is what? 1. P4 completed already. So next it goes to which one here? P5 process execute 1 second. Remaining is 1. Again it comes to your P1 process. 1 second it executes. Remaining is how much? 4. P2 completed. P3 is here. So P3 is going to execute for 1 second. It becomes what? 11. So P3 also completed. P2 completed. P3 completed. P4 completed. Now your P5 will execute for 1 second. It becomes what? 12. Completed. Only remaining is what? P1. So P1 1 second executes. 3 remaining. P1 1 second executes. 2 remaining. P1 is going to execute for 1 second. Remaining is what? 1. P1 will execute for 1 more second. 16 and completed. So 16. See, at the end also you have to get what? 16. That's it. Hope you have understood. Now, how to calculate your waiting time? So P1 process towards right. Here it is. The waiting time is how much? 15. But I need to subtract because here it has executed. It has not waited at all. So it has executed for 1 second. 1, 2, 3, 4, 5, 6. Means 6 seconds it has not waited, it has executed. That's why 15 minus 6 becomes what? 9. So P2 process. Here P2 where it is it? Here it is it. 6. Only 1 second here it is executed. So 6 minus 1 is what? 5. P3 process. P3 where it is it? Here it is it. 10. Minus here 1 second 1. Here 2. So how much P3 is? 10 minus 2 is what? 8 you get. Next P4 process. P4 here it is 3 and you not subtract, no more process will come. Next P5 here it is 11 here minus 1 2. So 11 minus 2 becomes what? 9. So average waiting time is 9 plus 5 plus 8 plus 3 plus 9 divided by total number of processes how much? 5. So if you add, I'll just check it out how much I'll get. Yeah, I'll get 34. 34 divided by 5 I'll get 6.8 millisecond. Now average turnaround time. Average turnaround time. So P1 process turnaround time towards right, that is 16. P2 process here it is there towards right, that is your 7. P3 process here it is there, that is your 11. P4 process, it is 4. P5 here it is there, it is how much? 12. Towards right, whatever it is. So average turnaround time is 16 plus 7 plus 11 plus 4 plus 12 divided by 5. If you add, I'll calculate. If I add, I'll get 50. So 50 divided by 5, that I'll get 10 milliseconds. So this is your round robin preemptive. So whenever they don't give arrival time, if they give arrival time, the calculation is different. We'll see that in your next problem. Yeah, whenever they give arrival time for round robin, you need to take one more queue called as ready queue, and this running queue is nothing but normal, the Gantt chart what you are writing. So here, normally what you mean by ready queue is whenever they give arrival time, so which all the particular process that is ready at a particular second. So in order to know what is the order of the particular process execution, that I will represent in which one are ready queue. So normally now I have just given, so this is the 4 number of processes there, arrival time I have given, and I have just specified time quantum of how many seconds here? 2 milliseconds. Every process is going to execute how many seconds here? 2 milliseconds. So here at 0 seconds, which process can execute is only your P1 can execute. Your P1 can execute. I will just place it in ready queue. So now running queue. So P1 can execute for what time? It is not for until next process time. I said right, round robin is going to execute only for what? The time quantum what you have specified. So it is going to execute how many seconds here? 2 seconds. Now see here, at 0 second only P1 executed. At 2 seconds, which all process can execute? So P1 is already in execution. So at 2 seconds, which all process can execute is P2 and P3. P2 and P3. So at 2 seconds, when P1 is executing, whenever it executes 2 seconds, okay, at that time, at 2 seconds, which all process can execute is P2 and P3. P2 and P3. And still P1 has not yet completed. It is going to execute 2 seconds, still remaining is how much? 3. If it is not completed, then what I'll do, after P3 process, I should place what? Your P1. Hope you are clear. Simple thing. See, 0 second your P1 can execute. And after that, if it is going to execute for the specified time quantum 2 millisecond, remaining is how much? 3. During 2 seconds, which all process can execute? P2 can execute, P3 can execute. See, during what? Second. And also what P1 can also execute. That's why if it is not completed, I should place after this. That's it. I should place after that particular thing. Hope you are clear with this. Okay. Now, what the next process going to execute is what? P2 process. What's the time quantum? 2 milliseconds. If it's going to execute 2 milliseconds, remaining is how much here? Here 2 seconds. Here 4. So it's going to execute 2 seconds. So 2 plus 2 is 4. So in this thing P2, if it's going to execute 2 seconds, remaining is how much? 2. Now check it out. At 4th second, which all process can execute? P2 is under execution. P3 is already in your queue. So which will enter the queue is the new process I should write. That is your P4 will enter the queue. And P2 has completed, not yet completed. If it is not yet completed, place after that. Place after that. Hope you are clear with this. Hope you are clear. So at 4th second, what happens is your P4 will execute. P4 will execute. And P2 has not completed. So I'll place after P4. I'll place P2 in your ready queue. Hope you understood with this. Okay. No more process will come. So I'll just continue. So P3 process. Next process is which one here? P3. How many seconds is it? 2 seconds. If it's going to execute 2 seconds, it is completed. No, if it is completed, I need to write again. If it is not completed, I should write in the ready queue. So no more time is there. So completed. So P3 has done. Okay. Next process that has to execute is which one here? P1. How many seconds? 2 seconds. So if it's going to execute 2 seconds, remaining is how many seconds here? Still 1 second is there. If it is not completed, what I should do? I should place in your ready queue. Hope you are clear. After P1, which the next process is P4. P4, only 1 second is there. But time quantum is what? 2 milliseconds. So at that time, whatever time is there, you execute only for that second. So 8 plus 1 is 9. So P3 completed, P4 completed. So next, that is in your queue is which one here? P2 will execute for how many seconds here? 2 seconds. So it becomes what? 11. So P2 completed. So I need not write again. So next process is which one here? Only left out what? P1. It is remaining only what? 1 second. So it's going to execute 1 second. It becomes what? 12. That's 9, 10, 11, 12. 12 you should get at the end. That's it. Hope you are clear with this. So now you need to write the completion time and all. P1, where it is there? Here it is there. Here it is there. But right one you will take. So P1 right completion time, what is there? 12 it is there. Hope you got it. P2, here it is there, here it is there. Towards right, here. Completion time is how much? 11. P3, here it is there, completion time is how much? 6. P4, here it is there, completion time is how much? 9. Okay, same way, turnaround time, completion time minus arrival time. 12 minus 0 is 12, 11 minus 1 is 10, 6 minus 2 is 4, 9 minus 4 is 5. Waiting time, turnaround time minus burst time. So 12 minus 5, how much I'll get? I'll get 7. Okay, 10 minus 4 I'll get 6, 4 minus 2 I'll get 2, 5 minus 1 I'll get what? 4. So that's it. Now average waiting time, how much I'll get is, here it is. So 7 plus 6 plus 2 plus 4 divided by 4. And average turnaround time, 12 plus 10 plus 4 plus 5 divided by total number of processes, how much? 4. I'll calculate how much I'll get. If I add all these things, I'll get 19. 19 divided by 4 is 4.75 milliseconds. So if I add your turnaround time, I'll get 31. 31 divided by 4 is the total number of processes. I'll get what? 7.5 milliseconds. Hope you're clear. Whenever they give round robin and whenever they give arrival time, I should use one more queue called as ready queue. What is the order of execution? So once you write this particular order of execution, you can write your normal running queue. That is your chat normal thing. So hope you understood. I'll take one more problem as an example. You'll understand in an easier way. Thank you.